So to learn about the fundamental features of Python, I thought it would be fun to create sort of a sandbox where we can play around and create a network device emulator. We'll be creating a layer 3 router, a layer 2 switch, an ARP cache, and also an Ethernet hub. The Ethernet hub is the simplest one of those devices, so that's where we will start. And as we build this device emulator, we will learn about Python strings, receiving input from the command line, working with lists and integers, as well as creating conditionals through if-else statements, and finally loops. So let's get started. So I will build this emulator as a Python script. Every time I then run my script with the Python interpreter from the command line, I would like to emulate the forwarding logic of a hub. A hub works in the way that it has multiple ports, and whenever it receives a signal on one of them, for instance port 2 here in my example, when that signal comes in, it'll be replicated to all the other ports. So a hub is basically just a multi-port repeater. The only port that will not retransmit the signal will be the port that we received the signal on originally. So this is the forwarding logic that we should implement, and it will happen once every time I execute the script. As I'm executing my script and then emulating the boot process of my hub here, I think it should print out a message. So I do that by defining a new variable over here and assigning a value to it. We know that from networking configurations where we assign IP addresses, descriptions, port status, and so on. In Python, a variable name is a combination of letters and numbers and underscores. So I can decide the variable name right here. So boot message is not a reserved keyword in any way. I just made this up, and then I assigned the string Python hub is booting into that variable. And you can see that it is a string because I have these double quotes around them. This is a way for Python to know where the beginning and the end of the string is. So then I'll simply just print out that boot message. And when I say print, so printing has nothing to do with printing on paper. I'm printing this on the command line. So let's just save my script here and then run it. And I can see my message is simply being printed to the screen. If I wanted another line here in my boot message, let's add please wait, like this. And then I run my script again. I get a syntax error because I have an unterminated string. And Python is referring to this string right here because as I'm adding my line break, I'm also breaking the string. So Python doesn't permit that. If I wanted a multi-line string, including a line break, I would have to use triple quotes instead of simply just one pair of quotes. So now Python will actually allow me to add line breaks into my string. So the string begins here on line 1 and ends at the end of line 2. And this would be supported. I can even have line breaks at the beginning of the string and at the end of the string as well. And if I have that, then it'll be reflected in the output with empty lines right here. So every time I run this script, I would like to emulate the forwarding logic of receiving just one signal on one port. So I have to make a new variable that defines which port I am receiving the signal on. So let's just print that back out. And as you can see here, I didn't add any quotation marks. This is allowed because I'm working with a number. So that's the way that Python can differentiate between strings and numbers. Instead of hard coding a port number, I would like this to be a bit more dynamic. I want to receive the input from the user on the command line. So I can use the input function in Python for that. Whenever we invoke a function in Python, we need to begin and end with parentheses. And then inside of those parentheses, we have parameters. The parameter for the print function up here was boot message, and the parameter for my input will be a prompt. So let's see what happens here. I run the script again. And when my script hits line 7 down here, where I have the input function. It prints a prompt to me, generate signal into port. This is exactly what I see over here. And it then stops and waits for user input. I can then type my input and hit enter. And when I hit enter, the script will continue. And this is where it continues to line 8 and prints back the number to me. So string-based variables can be combined. They can be concatenated into new strings. Instead of simply just printing the port number back to the user, I can combine this into a better string that explains what's going on. And I can do that by combining the two strings. I have a static string right here, beginning and ending with quotes. And then I have the plus sign to combine that with another string, which is whatever input was typed into the command line. So now when I'm typing the number 4, the output will be receiving signal on 4. Actually, I would like my identifiers for these ports not just to be numbers, but to be Ethernet 0/something. And because I have 4 similar items right here, it makes sense to define them as a list in Python. So this is a collection of variables. And lists are defined with square brackets. So inside of this pair of square brackets, I have a comma separated list of values. So this is one value beginning and ending with the quotes. And these are the other values. So I now have 4 items inside of the list. When I define items like that, I can either do it on a single line, but Python also allows me to have line breaks to make my code more readable and not wrap around like what we just saw here. So now that I have this list of valid interface names, then I can use that in my code. How do we then access these values inside of a variable? We cannot just use the variable name. Let's explore that in the Python REPL. So if I just execute the Python command here, it takes me into an interpreter, which is called the read evaluate print loop. This is like a CLI of Python. In there, I can put any piece of Python code and play around with it to test the functionality of Python. So let's just grab my list definition here and paste it in. And I hit enter. I can then try to print it out. And this gives me back the list. You can see I defined it over multiple lines and with double quotes. It would have been perfectly valid to do it with single quotes and also on a single line. So when I'm printing it out, I'm just seeing the internal representation of that list according to Python. Now, if I wanted to print out just a single interface name here, I need to access one of these subordinate items. This is similar to like a subinterface on a router where you have a main physical interface. That would be my list in this case. Then I have the child elements below that, which I can access also with square brackets and then a number. So let's go for number 1 right here. This prints back the contents of that position in my list. And list positions always begin at 0. This is my item number 0, item number 1, item number 2, item number 3. So we can validate that by checking the contents of the other positions. If I'm going out of range, Python will show me an error with list index out of range. If I did this inside of my script, it will crash with a similar error message. So be careful not to go out of range with those lists. You can actually access lists from both ends. So right now I just used 0, 1, 2, and 3. You can start at the other end as well and count backwards if you wanted. You do that by indicating a negative number. So -1 would be the last entry. -2 would be the second last entry, and so on. So you can just count in both directions depending on what makes sense in your case. All right, let's put this to use inside of our Python script. I'll exit out of the Python REPL again. And then I think we should print out the valid interfaces as part of the boot message to make it more clear to the users what the options are. So I'm printing item 0, 1, 2, and 3. So now I can see my list of choices here, and hopefully that'll ensure that we don't go out of range. So I'll select port 1, and I get received signal on 1. So the positions I indicated here, they are numbers. And even though the contents look similar if I used a string instead, then this would give me an error, because the list indices must be integers, not strings. All right, so we need to handle that. So this actually gives us a problem, because if I wanted to change my status message here to actually include the real port name, like this, and I enter port 3, then I get the exact same error message, because the data that is returned from the input function here is always a string. But I can easily convert that back into an integer just by using the typecasting mechanism of Python, which will convert it into an actual number and not a text representation of the character 3 in this case. So I can convert my string-based port input into a real port number. This port number can be used to represent a position in the list. Let's see if that's better. Oh, it really isn't, and that's because I didn't change my variable down here. This is still referring to the original input, which was left unchanged. I simply just created a new variable here on line 19 with the name port number instead of port. So that's the one I need to use. You see, that seems a lot better. Receiving signal on Ethernet 0/3. So now we have covered strings, input, lists, and integers. So we are well on our way here. So now it's time to implement the actual forwarding logic that I talked about before. Now we've received our input and generated some output. We have a list of valid interfaces, and I think that that's a good basis for implementing the forwarding logic. So let's just recap that forwarding logic. Whenever I'm receiving a signal on a port, I want to send it out on all other ports. So my hop here has 4 ports. You could also imagine a hop with 3 ports or 10 ports or 50 ports. We can make Python go through any number of ports by referring to this list up here. It has 4 items, but it could have less, it could have more. So to make that dynamic, we can create a for loop. So in Python, I can define a block of code that will be executed multiple times or only under certain conditions. And these code blocks are always indicated with indentation. So you see right now I have added 4 spaces down here. That's a common practice. You can use 2 spaces as well if you wanted to, but I prefer 4, and that's the case for most open source anyway, so that's my recommendation. Everything that then has these 4 spaces of indentation will be considered a code block. The for loop here references 2 different variables. It references an existing variable of hop ports. This is the list that it will iterate through. And then for every item that it finds inside of that list, it will populate the value into egress port. So that means that egress port will contain Ethernet 0/0 on the first iteration, and then it executes the entire code block. It then sees that there are more items and populates with the next value and executes the code block, and then the next value and the next value and so on. So that gets quite clear. If we just try it out here, we can see the multiple output entries right here. So we are well on our way with the forwarding logic right now, and we also learned about for loops. But that's a problem because the signal is being retransmitted on all 4 ports, and that's not what I wanted. I wanted an exception down here to not forward out of the incoming port. So to do that, we need Python to behave differently under different conditions. And this is done with if statements in Python. So one of the beautiful things about Python is that the syntax that we use with all these reserved keywords can be taken quite literally. So if you have good variable names and you read out the code aloud, then it should literally make sense. So to make that really work, it's important that we reference our values with very easy to understand variable names. So I'll just assign a new variable with a better name. Ingress port to the value that we extract from the list, because then our code becomes a bit more readable right here, as well as in the if statement that I'll create now. So if the egress port is the same as the ingress port, then I want to print out a different message. So I added a new level of indentation here, indicating yet another code block. So the if statement here will execute whatever code is in the code block that follows it, only if this condition evaluates to true. So if the egress port is in fact the same as the ingress port, it will just not transmit out of that port. But in all other cases, so there can be 2 different conditions. Either this loop has reached the same port that we received the signal on, and it'll not transmit, and then in any other cases, it will in fact transmit. So let's see how that looks. And now we get the result that we expected right here, because I'm inputting the number 2 that converts into the port name Ethernet 0/2. And then when Python loops through the list of available hop ports and it finds that the ingress port was the same as the current port, it'll not transmit out of it. So now we also learned about if and else statements. I think we should put in another if statement as well, because that's a problem with my code here. I can still input a number that is out of range. So instead of my script simply crashing, I want the error message to be a bit more clear. And I can choose my own error messages if I make an effort to actually catch those cases where I receive invalid input. The issue is here on line 20. So right before that, I need to make sure that I actually received a valid port number. So let's create a new if statement here. So if the port number is lower than the length of the hop ports, okay? If that is the case, then I'll execute the following code block. And in any other case, I'll provide this error message instead, invalid entry, and then my script should just exit right after that. So let's try that out. Entering port 6. Oh, I didn't save the file, so I can see that in VS Code up here that there is a white dot. If I save the file, then that disappears. So let's try again. And I just get invalid entry 6. So that's all good. If I provide a valid entry, I get my forwarding logic. What if I try a negative value? -3. Now this is technically correct from a Python point of view because I'm just accessing the list from the other end like I showed previously. But what if the number was even lower, so -8? Then I'm back at the list index out of range problem again. So maybe my if statement down here isn't good enough. I should not only check if the port number is lower than the total length of the list. I should combine that with another verification that the port number needs to be above or equal to 0, because that'll prevent me from doing an entry like this. So there are lots of other things that could go wrong here with this code, and you will probably need to do a lot more error handling than this. But let's just keep it basic for now. And maybe I'll leave it to you to try and figure out what happens if I enter something that is not a number right here. I think you should try that out on your own by reconstructing the code that you have seen in this video and try to run it on your own. So there's one more thing I would like to show you about looping. So for loops will continue until it reaches the end of the collection that it is looping over. But we can also do a while loop. So a while loop will evaluate whatever is right after the statement here and then continue to run the following code block until this one turns into false. So let me just add some indentation here to make that into a code block. I'm setting a static true right there, which will make it run literally forever. So now I can generate signal into one port, and then I'll get the prompt back to generate another signal, and I can just continue like that until I have an invalid entry, and the script will exit based on my exit function down here. So this also means that it's very important that you mind the indentation, because the indentation is a very key part of the syntax in Python. It really describes where code blocks begin and end. And this is really the basis of the logic that you're implementing in Python. So let's just add while loops to the list as well.